All right, so what we've done over the past few days now, adding, subtracting, multiplying, and dividing, multiplying monomials, is leading us to multiplying polynomials. So the first thing is just a monomial times a polynomial. So a monomial is just one term. So this guy right here, this is a monomial because there's only one term. There's no plus or minus signs in between. Okay, this one right here, the 2x and minus 4x, this one and this one, there's two terms there. So technically this is a monomial, f of x is a monomial, times 2x minus 4, which is a polynomial. Okay, so this one is pretty straightforward, and I'm sure you guys are being like, I can't believe I have to watch this, but hey, why not? Why make it hard? Okay, so here we go. So I'm going to take 3x and I'm going to write it like a multiplication problem times 2x minus 4. So again, this is just function notation used to ask the question in a different way. So we're going to take the 3x, which is a monomial, and multiply it times this one and that one. That's it. So it's what we did last time. So 3x times 2x, what we did yesterday or whatever, the last day you saw a video. 3 times x is 6. You have 1x here, another x here, so that's x squared. 3x times negative 4. You multiply the outside numbers. And then x, this one doesn't have an x at all, so it's just x. So since that one doesn't have an x, 3x times 4 is just 12x. The exponent doesn't change. Okay. All right, so then same deal here. We do negative 2x to the 4th. This one's fun because you get extra variables in here, but the process is still the same. Okay, I just have to move this down a little. So we take the 2x, negative 2x to the 4th y, we multiply it times the 3xy, and then we multiply it times the negative 1. So same deal here. You multiply the negative 2x. Okay, so you multiply the numbers first. Negative 2x times 3 would be negative 6. X to the 4th and x, so those are the variables. So here I have 4 x's. Here I have 1, so that would be x to the 5th. And here I have y and y, that's y squared, right? Because there's 1, and that becomes a squared. Now, this one, the negative 2x, y to the 4th, y to the 1st, times negative 1, all that's doing is multiplying the outside. So it's negative 1 times negative 2, which is positive 2. And then the x 4th, y to the 1st kind of comes along for the ride. So it's just a bunch of multiplying monomial problems altogether. And that's really all any of this is. So here we go. We're multiplying a binomial times a binomial. So this is a binomial. Binomial means 2. Bi means 2. So we're multiplying each of these times the other one, whatever. Okay, so what I like to use is the tabular method. Obviously, you don't have to. I'm not asking you to change your whole life because of me. But I like this method because it's really easy, and when we get to factoring, it makes factoring a little bit easier for us. Okay, so we're multiplying x plus 2 times x plus 5. So g of x times h of x. Just put those together. That's all I did. So you don't really have to put the times sign in between the two. When there's no sign, we know it's multiplication. Okay, so what has to happen if I have to multiply the x times both of those and the 2 times both of those? Now you could just do that, but I like to use what's called the tabular method, which means we just say if this has 2 terms, I'm going to put one term here, and each one is going to get a box. So it's like a multiplication table. Okay, you can put the signs if it makes you more comfortable. And then to get inside the box here, to get into this box, we have to multiply this one and this one. Okay, so x times x is x squared. And then to get inside this one, we have to multiply this one and this one. So x times 5 is just 5x. To get here in this box, we do this and this. And this one right here is 5 times 2. Okay, so once we're here, that's great. Everything's been multiplied. Now all we have to do is combine like terms. So that was the multiplying piece. So first we multiply. And then the next thing we do is we combine like terms. So it's like what we've done over the past 3 days, or 4 days, whatever, all together. So first you multiply to get in the box. Once you're in the boxes, you can see that these two are like terms. The other two are not. So x squared, I'm going to add the 5x and the 2x. So remember, you're just counting how many you are. So there's 7 of them. And there's your answer. Okay. Not a whole lot of thinking is involved when you're doing the tabular methods, which is what I like. All right, so this one is saying k of n squared. Okay, so in order to do k of n squared, I have to do 2n minus 3. 2n minus 3 squared. So when I square something, we did that before, it's 2n minus 3 times 2n minus 3. So it's basically the same exact thing that we just did on the last one, but it's just another way of asking the question. So again, I'm going to use the tabular method, and that's the way I'm always going to use, just for consistency. So to get in this box, it's 4n squared. This is negative 6n. Remember, it's this one and this one to get here. Here again, it's negative 6n, and then it's positive 9. Negative 3 times negative 3 is a positive 9. Combine like terms, the only one that has the same variable and the same exponent are those two. So I just write the 4n squared. I can even write the plus 9. Okay, but in the middle, negative 6 and negative 6. So remember, we're adding here. We're combining like terms. So when we have both signs are the same, we combine them. We just add 6 and 6, so we get 12. And we keep the sign so it's minus. Okay? So this one, it can get as big, and it doesn't get any harder if you use the tabular method. The other methods can get just a little bit clumsy. Okay, so this one has 2 terms, so I put it here and here. This one has 3, so I gave it 3 boxes. 1, 2, 3. Okay, so then we just combine. It's one simple multiplication for every box. So 3x and x squared is 3x cubed. 3x and 2x is 6x squared. So this is negative 21x. Negative 2x squared. Negative 4x. And positive 14. Hopefully I did that okay. So now we combine like terms. This one has a few more. So this is one set of like terms, and this is another. If we're using the same variables, generally the diagonal will help, but sometimes you have to look. So 3x cubed does not have a like term, but 6 and negative 2 do. So 6 and negative 2 are opposite signs, so we subtract the numbers. 6 minus 2 is 4, and we keep the sign of the bigger one, which is a 6. So then we have negative 21 and negative 4. Notice, I hate when I do this. The signs are the same. This is negative 4x and negative 21. So I'm adding those numbers to 25. Keep the sign. And then 14. So it's just multiplying and then adding. You just have to keep those straight. Alrighty, let's do it here. So n minus 3. Those are my 2 terms. And then my 3 terms, n squared minus 2n plus 1. Okay, so now when we're doing this, we just do our multiplication first. So when you multiply, exponents change. So here, this is going to become n to the third. This is negative 2n squared. This is n. You can put 1n if it makes you feel better. Then negative 3n squared. Multiply negative 3 and negative 2. Again, we're just multiplying. Positive 6n and negative 3. So we just straight up multiplied there. Now when we're adding, when we're combining like terms, exponents don't change. So here n to the third stays the same. These two are like terms. So I'm combining negative 2 and negative 3. Those are the same sign, so it's negative 5n squared. Notice the exponent didn't change here. It only changes when I go into the box, when I'm multiplying. So 6 and 1, the signs are the same. So we're just adding the numbers, and there we are, all done. Hopefully this wasn't too bad. This was the hardest lessons of the 4, but hopefully you understand. We'll see how you do. Bye.